Hi, this is Aaron with iBoard Repair, and today I'm working on an iPhone SE2 that has randomly died on my customer. He didn't drop it, he didn't water damage it, it just spontaneously died on its own. In this video, I want to show you how I can quickly identify the problem on the motherboard by interpreting my DC power supply amperage draw when I prompt this phone to boot. Let me show you what I'm working with. So my first step when I'm working with a no power board is to take my DC power supply probes here and tell this phone to turn on by shorting the power button, and I can view what my amperage draw looks like when I do that, and that will give me a good indication of what's wrong with this board. In this case, we can see that I have like a short amperage spike. So it just it shoots up really quickly and then back down. So when I see this issue, I can tell you from experience, it's almost always going to be a shorted power rail. So what I'll be doing is checking all the PMIC outputs, the NAND power rails and the RAM power rails, and I'm hoping to find a short on one of these lines. I can pull open my iPhone SE2 board view here, and I'll tell you which power rails I normally check. I check most of the outputs from the PMIC, and the way I identify that is just by clicking on these coils here, and I'll check the related capacitors. So PPDCS S1, OV9 S1, SRAM S1, CPU P core, CPU E core, PPGPU, AVE S1, PP1V2 S2. All these lines are what I'll be checking. The other good lines to check are your NAND power rails, so 3VO NAND here, 1V8 NAND, and OV9 NAND, as well as my RAM lines. So 1V8 S2, 1V1 S2, and OV6. OV6 I'm not actually sure if that's RAM or CPU, but it's an important line to check. So I'll turn my multimeter onto diode mode, and I'll check those lines. And I'm not really interested in the exact values. Right now I'm just looking for a full short, because that amperage draw usually indicates a full short, not a partial or something like that. So I'll just be checking all these capacitors, and I'm looking for that full short. These all look good so far. I can kind of see the pathways of where this coil leads to that connects to these capacitors. So I don't necessarily have to keep looking at my board view. Some of these are going to be low resistance lines, so they'll beep even though they're not necessarily short. I haven't found one yet, but you'll know it when I measure it. Like, this is PPGPU, and it's very low resistance, so that 0.006, that's not actually short, that's normal on this line. All of these look good so far, so I was hoping one of these might be the issue. It doesn't seem to be the case. We'll measure NAND next, and I've already actually measured these. I know they're not short, but I'll just show you that. These are the only ones I've measured so far. So those are good too. So yeah, I should check the RAM lines now. It's also going to be worth it to check these coils that are around the CPU. I haven't checked that, as we can see. So I have this fourth capacitor here. PP sock I need to check over here. 1V8 is the RAM line. OV6 over here. Where was 1V1 at? Oh, 1V1 was that first one I looked at. Okay, yeah, so I'll check this one first. And then these ones next. So it was that fourth line, fourth capacitor. And that looks good. That was my 1v1 RAM line. And then it was these two staggered capacitors was my sock line. And that's another low resistance line. I'm fairly certain that's a normal reading. And I can kind of verify that. I'll show you. So that was this one here. But if we zoom in on my PMIC here, we can see that the 0.04 is a normal reading on this line, and that's right around what I had. So I'm definitely not worried about that one. Next is the 1V8 S2 line. This is another RAM line. I will go ahead and check that probably right here. So that was right over my audio IC. I believe it was this one. And yeah, it looks like this is actually full short. So this was my 1V8 RAM line, if I can remember. And that line goes to a lot of places. So it's going to power my RAM, but it powers a few other chips. It powers Hydra. And that's actually relevant because this customer, I believe, said they were having a charging issue before this died. So this is my initial intake. Started to be more challenging to charge, but would always charge up to 100. Got down to 10% on April 19th and wouldn't charge once plugged in, turned off, and haven't been able to charge since. So that sounds like it could be a charging IC issue. So that definitely sounds like a charging IC issue, and we can see that that line does power my charging IC here. This is a really strong suspect. And I have to really hope it's not my RAM chip itself, because changing RAM is really difficult and not a fun thing to do. So I think what I'm going to do is inject voltage into this capacitor here. And I'm going to look for heat on this chip first. And I hope I see heat here. If I do, then I know I can just change this chip. It's also fine if I just see a capacitor shorted. That would be a very easy fix as well. So let's test that. So I have my thermal cam directly over the charging IC. I'm going to set my DC power supply to 1.8 volts, and I'll inject into that capacitor. So I'm not seeing any heat above the charging IC. So let's see if we can find it somewhere else. I'll try to overlay my thermal cam here so you can see it when I find the actual culprit. Still not seeing any heat. I'm not seeing anything. And that's a bad sign. This is likely going to be RAM if heat shows up nowhere else. So I have a few more spots I can check, and then I'll pull the shield over the CPU and see if it's possibly RAM after that. I was really hoping this was just going to be the Hydra chip, the charging IC, because that would have been the easiest thing to change. I have another charging chip right down here, so I'll check that as well. I can inject into this small cap right here. Oh wow, interesting. I see long screw damage here, and that's where I'm seeing heat. I was not expecting that at all. So I'll overlay this thermal cam so you can see it. It's a little easier when I give it a blast of freeze spray. So if I inject into this tiny cap right here, I can see heat showing up in the middle of that screw hole. You see that? It lights up right in there. And I don't think I've ever seen this problem on this model, so that's interesting to see. I am very glad it's not RAM, because this is still fixable, even though long screw damage is a hassle. Long screw damage is when you stick a screw into this hole that's longer than it's supposed to be and it scrapes into the motherboard. So let's see if I have, yeah, I do. I have the layers here. So it's not the first layer. It looks like it's the second layer possibly. Still actually don't see it. Yeah, very interesting. I'm not seeing a direct line under here, but the board views aren't always correct. It has to be there because that's where I'm seeing the heat. Let's see if I have a 1v8 IO line short as well. So I'm going to see if this line is possibly short. I'll measure at this capacitor. No, that line's good. That's also another really good one to check if you see a short like this. Very interesting. So I'll remove this screw hole and I'll scrape some of these layers and let's see if we can clear that short. So I'll just take a sharp razor blade and start scraping here. And I'm hoping none of these lines are cut. I have some display lines that are underneath here as well. And you know, if they're broken, I'm going to have to repair those to have image work on this device as well. I'm a little bit concerned now that there's a secondary issue with this device as well, because this wasn't what the customer reported. They said it died on its own, and this is technician damage. If they said it died after like a screen repair or something like that, that would make a lot more sense. But I'm kind of concerned now that it died and then they took it somewhere else, and then those people caused this secondary issue and there's still a primary issue to address. Things are getting quite small, so I think I'll remove my Barlow lens to get even more zoom. This is as zoomed in as I can get currently. When I take off my Barlow lens, I can go a lot further. I'll be able to see quite a bit more clearly now. It's always good to just check, make sure I'm still short. I'll just do that quickly now. It looks like it's already clear, so I don't need to dig any further than this. That's great. Hopefully that's all I need to do. I may have more issues down there, but I'm not sure. So if I go back to this original capacitor I was measuring the short at, I should no longer see a short at that line. And I do not. Okay, let's see if it's booting then. So I'll take my DC power supply probes again. And now when I prompt this phone to boot, I should see hopefully a normal boot sequence if I have no other problems. There we go. I think I was just not getting a good press on there. So this is a much more normal looking boot sequence. And that looks like it's booting. So I'll take my parts now, I'll plug them in, and let's see if we have image. There's a possibility I still don't have image on this device because I have a lot of image lines going under that screw hole as well. It's also interesting, I'm not sure what line it was touching. There's not too much copper exposed, so I guess just something right there is part of that 1V8 line. And if I prompt this to boot, let's see what happens. Normal amperage draw on my ammeter, and we have an Apple logo, so that's great. And we're in. Great, I have access to the data. I'll take this apart for now. And a couple takeaways from this board. So my amperage draw indicated that I had a power rail short, and the short was definitely in a spot that I wasn't anticipating. It was caused by long screw damage. Another key takeaway is you can't always listen to your customers, because the customer said, she said it didn't go anywhere and that this phone died on its own. And this is obviously technician damage. And it does have, it had signs of work on that board. So that battery looks all mangled. So it's definitely been opened. So she took it somewhere, and that technician put the wrong screw in the wrong screw hole, and it caused a line on this board to become shorted to ground by like digging that screw into the motherboard and pushing those traces down a little bit. So yeah, so that's why I think it's important to know how to interpret your DC power supply. This was a very vague problem, and I don't think I've ever seen long screw damage in that spot on an SE2, so I'm not sure if I would have just looked there just to check. But knowing that I had a short on that line, I was able to inject voltage into that line, and I was able to see with my thermal cam that I was getting a heat spike underneath that screw hole. So just filleting the top of that board and removing some, that top layer, I was able to clear the short, and this phone's turning on, and I'm able to pull data for my customer. So thanks for watching this video. I hope you learned something. I hope you stop by again, and I hope you appreciate these types of videos. Bye-bye.